Hello guys, I am Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 17 on using the Arduino with Python. Now in lesson 16 we had I think some exciting work where we showed you how you can talk between Python on a PC and the Arduino using the Ethernet cable. And the exciting thing about this is it allows you to set up things where the Arduino can be just about anywhere and talk to just about any PC by setting up a client-server type relationship. And this is a little bit of a tricky thing to do, and so the example that we gave you in lesson 16 was a very simple one where basically we set up a simple client-server type relationship. Arduino was the server, Python was the client, and Python would simply send a string to the Arduino. The Arduino would read the string, based on the string, send something back, and so it was just sending a string from the client Python to Arduino the server, and then the server Arduino would respond back to Python the client. And so we were just sort of showing you how to get a data packet and passing it back and forth. And it was just a simple example that didn't involve any sensors or any circuits or anything like that, because basically in lesson 16 we just wanted to get you where you had the Ethernet working and you could pass things back and forth. What we're going to do in this lesson is we're going to add a sensor and kind of show you a client-server type relationship where you're actually doing something. The sensor we've chosen is the most excellent Adafruit BMP 180 pressure and temperature sensor. The reason I chose this one is because this sensor can measure two things. It can measure pressure or it can measure temperature. And this allows us to kind of take a simple client-server concept up to a little bit more sophisticated level, that the measurement that is going to be made is going to be based on what is requested from the client, which is Python. So Python can send a command, temperature, and then if Arduino receives the temperature command, it first of all makes the temperature measurement, and then after making the temperature measurement sends the measured temperature back to Python. Then if Python wants pressure, it can ask for pressure, goes over to the server, the Arduino. The Arduino will then measure pressure, and then after measuring pressure it will send that data back. And the neat thing about this is that you could have multiple computers and multiple Python programs, and they could be querying or asking for things from this Arduino based on what they want, when they want. And so you really start developing a pretty powerful capability when you can do this. In order to follow along on this lesson, what you need to do is you need to have your Adafruit pressure and temperature sensor hooked up and set up. If you really want to follow step by step what I'm doing, use this pressure and temperature sensor. And we have already explained how to hook that up, and so I won't go through that. I'll just show you where you can find it. If you go to my most excellent website, TopTechBoy.com, you will go to Using Python with Arduino, which is right here. You click on that. These are those Python Arduino lessons, and you come down to lesson number 9, and this shows you how to hook up the pressure and temperature sensor. You probably don't need to watch the video and go through the whole thing. Probably what you really need to know is how to hook things up. VN to 5 volts, ground to ground, SCL to A5, and SDA to A4. It takes 4 wires. In just a couple of minutes you can have the pressure sensor hooked up to the Arduino. The other thing you're going to need, of course, is an Arduino, because it will be the server. I am using the Arduino Nano because that is what I have here. You can easily use the Arduino Uno. It would be identical. I'm using the Ethernet Shield, which is made for the Arduino Nano. You can use the Ethernet Shield made for the Arduino Uno. If you go to this lesson, lesson 17 on TopTechBoy.com, I've got some links if you need to pick up that hardware. Again, there are some very inexpensive Chinese knockoffs on the Ethernet Shields. I have not had good luck with those, and so I suggest in a lot of times you can make out okay buying the cheap knockoffs, but for something like the Ethernet Shield, I really recommend getting the official Arduino Shield. And I've got some links on this lesson if you need help running down the hardware. Okay, so I'm going to assume that you have got this set up. The Arduino is plugged into the Ethernet Shield, and it is connected properly to the BMP 180 pressure sensor. So let's go in and let's start trying to get this thing set up. If you have not done so already before listening to this lesson, you really need to do lesson 16, because lesson 16 goes into great detail of how to get the Arduino and the Python talking together over Ethernet. It gives a lot of the details on how you set up your IP addresses and so forth. And I don't want to go through all that again. And so before you undertake this lesson that I'm talking about now, lesson 17, you need to make sure that you have done lesson 16. Okay, and the way you get to lesson 16, again, toptechboy.com, go to using Python with Arduino. Okay, come down, I've got all these lessons listed. Lesson 16, you want to make sure that you have been through before you try lesson 17. Okay, but let's get going here and let's see if we can get going on lesson 17. And so what I need to do is I need to open up my Arduino IDE. And so let me get a window up here, a nice, fresh, clean, empty window, and we will start developing this program from scratch. Okay, some of this is going to be repetitive from lesson 16, so I'm not going to go into a whole lot of detail because we talked about these things a lot in lesson 16. But the first thing we need to do if we're going to use Ethernet is include the Ethernet library. So we include Ethernet.h. So we're loading up that Ethernet library. This should already be in your Arduino IDE, so you don't have to install a library, you just have to load it. It should already be there. So we're going to load the Ethernet library. Okay. The next thing we want to do is we explained in lesson 16 that the easiest way to do this thing is using UDP. And so we need to include the Ethernet.udp. You have to do this just the way I'm doing it. Capitalization matters. Okay? And then we're going to load the UDP library. Okay? This also needs the SPI library, so we're going to load include, and we're going to load SPI.h. Oops, that is not good. Okay. Load SPI library. Okay, that's what we need. Those are the libraries we need to make the Ethernet work. Now we're also using this pressure sensor, and we need to load the libraries for the pressure sensor. It is going to need the include wire.h. That does not look right. Capital W, wire.h. And I am like that. Okay. So we include wire.h. Imports the wire library. Okay. Now you also need the libraries associated with the Adafruit BMP085 sensor. And really, I go through detail of how you have to install this library. This library does not come with your Arduino IDE. And to see how to install that library, go back to that lesson, toptechboy.com, using Python with Arduino, and then it's Python with Arduino lesson 9. And that lesson will show you how to install the libraries from the Adafruit website. And so I'm not going to go through that again here. You can go back and look at that, or you can just go and load it up. Okay, so now we have include wire H, and now we've installed the library, so we need to load it. So we're going to say include, and then it is Adafruit BMP085.h, like that. I'm going to check that. Adafruit BMP085.h. Okay. Import the pressure temperature sensor library. Okay. now we need to create an object. Okay, we've loaded the library. We need to create an object that we will use to interact with the sensor. And so it is Adafruit BMP085. So that's the call to the library. And then we create the object, which I'm going to call my sensor. All right, you can call, what matters is this has to be exactly like this, and then you can call it whatever you want. I'm going to call the object my sensor. Okay, and so we're going to create a sensor object. And then this is the name that we will use then to interact with the sensor. So hopefully if you went through lesson 9, all of this makes a whole lot of sense to you. Now we're going to need some variables. We're going to be measuring temperature, and we're going to be measuring pressure, so we need to create some variables for that. Pressure and temperature I'm going to make as floats, and actually we read from the sensor in centigrade, so I'm going to create something that I'm going to read into, which is temp C. Okay. Declare variable for temp and C. Okay, but since we're in the United States, or at least I am, and I really like to think in Fahrenheit, I will be converting that temperature in centigrade to temperature in Fahrenheit. I will need a variable for that, so I'm going to have a temp F. Declare variable for temp in F, capital F. Okay, now we're also going to be measuring pressure, so I'm going to float, and I'm going to create pressure, variable for pressure, and declare a variable for pressure. All right. Okay, we've got our variable set up, and we have got our libraries loaded. Now we need to go through some overhead to create the to get the Ethernet working. And really, I'm not going to explain this very much, but really you need to go back and watch lesson number 16, and it will explain all this to you. You have to put in the MAC address for your Arduino shield. This is something, don't use what I'm typing here. This is something, go back to lesson 16, and what you have to see is that you have to use the MAC address and the IP address for your network, or for your router, and for your Ethernet shield, and you've got to work that out yourself. You've got to go into either talk to your network administrator, or what you have to do is you have to go in and open up your router, and you've got to get the router to agree that these are the you've got to agree on the IP address and the MAC address that you're going to use. Your router is going to want to use a different MAC address probably, and is going to want to use a different IP address probably. So you have to go in and you have to work that out yourself, or I kind of give you a little bit more detail in lesson 16 on how to do that. But for me, this is my MAC address, and I declare the variable as a byte, and the byte is a variable called MAC, and that MAC is an array. Okay, so variable type is byte, the variable name is MAC, and these brackets indicate that it's an array, and I'm going to go ahead and put a value into it. And I hope I can do this right. So for me it's 0xDE, comma 0xAD, comma 0xBE, comma 0xEF, comma 0xFE, comma 0xEE. Close curly. Okay. Assign MAC address. All right. What's important is two things. This MAC address needs to be different than any of the other MAC addresses on your network, and your router has to agree that this is the MAC address that you're going to use with the IP address that you're going to use with the shield. On most hardware, the MAC address is hardwired in. On the Arduino, you have to sort of put the MAC address in software, and then when you fire the thing up, it will start declaring itself as this MAC address. The main thing is that, you know, again, two things. This MAC address needs to be different than all the other MAC addresses on your network, and it needs to be something that your router or that your network administrator agrees is going to be used with this particular Arduino and Shield. So for me, that is the MAC address I'm using. Now I have to give it an IP address, IP address. Okay, so I'm declaring, and I misspelled something, APP, two Ds, okay. And then this is a variable, and I'm going to call it IP, like that. And then I'm going to give it the address that I'm going to use. And so it's 10. Normally you'd say 10.1.15.243, something like that. In Arduino, when you're defining it, you put the different parts in separated by commas. So it's for me, it's going to be 10, 1, 15, 243. Close the parentheses. Okay. Assign the IP address. That's no good. Okay, now you got to go into your router and you got to make sure that your router agrees that this is the IP address you're going to use and this is the MAC address you're going to use. For you, you're going to be on a different router, so you do not use the IP address that I'm using here. You get an IP address from the router. Okay, you get an IP address from the router. That's beyond what I can really explain how to do. But the bottom line here is you have to know enough about your router that you assign this MAC address and whatever IP address you're going to use in the router, and you associate it with this Arduino. Okay, so IP address for me is 10, space 1, space 15, space 243. I think that's right. You're going to need to have a port to talk over, so I'm going to say unsigned int. I'm going to declare it an int, and I'm going to call the variable local port, and we are going to be talking over port 5000. Okay, assign a port to talk over. Okay. All right. When Arduino reads a packet over UDP, you have to read into a variable. You have to read it into an array, a character array. So I have to declare a variable that I'm going to read into. And so what that is going to be is, it's a character, or a char, okay, and I'm going to call it packet buffer. All right, and now I have to dimension it. This Ethernet has a variable which defines the maximum packet size, and so I'm just going to use that constant, which is UDP underscore TX underscore packet, UDP TX packet underscore max underscore size. Okay, and so this is something that Arduino will recognize as a number, and it's the number you need. So you just got to put it in just like that. So we're going to dimension a char array to hold our data packet. Okay. We don't, once we do the reading, we don't want to have to deal with a char array, so it's really a lot easier if we convert that to a string. And so what we're going to do is we're going to create a string array, and that's going to be data request, and that's going to be the string that we convert packet buffer into. And so this is a string for our data, because to me strings are a lot easier to work with than the char arrays. Okay, we're going to be reading to see if there's a packet there, so we need a variable to read the packet size into. So we're going to create a packet size variable, and this is going to be the size of the packet. Okay, and then I need to create an Ethernet UDP object, so I'm going to say Ethernet UDP, and that's going to be UDP, like that. So this is going to define a UDP object. Well, maybe we'll say it's creating. Okay, understand that this capitalization is important. This Ethernet uppercase U, uppercase D, uppercase P, that's going to call that library, and that's going to create this object UDP. And this object UDP is the one that we will use. We will use that object then to interact over the Ethernet. Okay, so I think we've got most of that overhead taken care of, and so this should load our libraries, this should create our variables, and this should get things ready to get the Ethernet going. And so that's a lot of our overhead. Now there's some other overhead we've got to do in our void setup. I always like to do serial.begin 9600. I always turn my serial port on. Okay, so I initialize serial port, because you never know, you might want to pop up that monitor or print something out on your serial monitor, so we're going to turn that on. Now we need to start our Ethernet, so I do Ethernet.begin, and I've got to tell it two things. I've got to tell it the MAC address. Well, I've defined the MAC address up here, so I just say MAC because I've got a variable with that in it. I've got to tell it the IP address. Well, I created the IP address up here, and so I will put IP like that. Okay. So that should initialize the Ethernet. Okay. We also need to initialize the UDP. What did we call our UDP object? We call it capital U, little d, little p. So I go capital U, little d, little p, like that, and then dot begin to turn it on. And then I got to tell it where I'm talking. What port am we going to talk over? We're talking over 5,000. But I've got a variable here, so I put in the variable local port, like that. Okay, so this will initialize UDP. Okay, like to give it a little time, make sure that it gets all this stuff going. So I'm going to put a little delay in here, 1500, like that. That's just a delay, give it time to get going. Now I need to turn my Adafruit sensor on. I need to initialize that. So what did we call the sensor object? We called it my sensor up here. So I got to get that started. My sensor.begin. Don't have to pass it any parameters, so we just go like that and initialize pressure temp sensor. Okay. So I believe we have everything turned on at this point. So all of our stuff is turned on. All right, this is the server. The Arduino is the server. It can do two things. It can measure pressure or it can measure temperature. And so what I'm going to set this up is it's just going to sit and wait. It's not going to do anything until somebody asks it for something. What are the two things it can ask it for? Go out and measure pressure or go out and measure temperature. If it asks for pressure, then we're going to have the Arduino go out and make a pressure measurement and then send the pressure reading back to the client. If it asks for temperature, it'll go out, it'll measure the temperature and send the temperature back to the client. And so this is a little more sophisticated than what we did in lesson 16, because we're actually going out and taking action. We're making a measurement and then we're returning the requested data. Okay, so that's what we're shooting for here. So let's get down in here, and I believe we are ready to get into our loop. Okay, so this thing just needs to sit and wait for a request. And what it has to do is it has to go out and it has to look and see if a request has been made. And the way we do that is we look at the packet size. And if the packet size is 0, nobody has asked for anything, so we just loop through and don't do anything. Has anybody asked for anything? No, we loop through and don't do anything. At the point someone has asked for something, there will be a packet there, and therefore the packet size will no longer be 0. So what we want to do is we want to read the packet size. Excuse me. Packet size. And the way we read that is with the command udp.parse packet, like that. And what this is it reads the packet size. Okay, understand, it is not reading the packet. It's just reading the size of the packet. If packet size comes back 0, there is no packet. If the packet size comes back with something other than 0, when I do udp.parsePacket, if that is not 0, that means someone has asked for something. If someone has asked for something, now I better go in and do some other stuff. So what do? I come in and I say, if packet size is greater than 0, that means someone has asked for something. Okay? And then I need to open this. So this is an if statement, and I'll say if packet size is greater than 0, that means someone has sent a request. So if someone has sent a request, then I need to do something. I need to do these things. If someone has asked for something, I better do something. Well, what did I better do? Well, I better read the packet. So I do udp.read. This is the command. The read I have to put into a variable. So I'm going to do the read with this UDP read. I've got to put the packet somewhere. Where do I put the packet? I put that in that array that we created, that char array, which we called, better spell right, packet buffer. Okay. So when I do the read, I'm going to put it in this char array called packet buffer, and then I have to tell it in the read what size to read, and I'm just going to do UDP, and I'm going to copy it from up here because I don't want to make a mistake. This was that max size. Well, we're still going to use that, so I'm going to say copy, and then this is the size that I'm going to read, whatever the max size is. So this is not the smartest way to do it. This is not the most efficient way to do it. If you really knew what you were doing, you would do it differently, but this is a class designed for high school students, and we are just trying to kind of get something that works so that we can go out and use this and build projects. And so we're just going to do it the way that works and is simple, and not the efficient, elegant way that people who really knew what they were doing would do it. But what we can do is we can read it by udp.read. We put the information into packet buffer, and we give it this size. Okay, so what are we doing here? We are going to read the packet, or read the data request. Okay, so we're going to read it. Now we know what this should be is, okay, well, this is going to be a character array, and we don't like working with character arrays, so we are going to convert it to a string, and we do that with the command string. So we're going to turn it into a string. What are we going to turn into a string? Well, we're going to put it in the variable data request. So that is the string variable that we created. So we're going to create a string data request, and what are we going to create it out of? We're going to create it out of this character array packet buffer. Okay. Convert character array packet buffer into a string called data request. Right? So we read the data into an array called packet buffer. We convert that packet buffer array into a string that we call data request. Now, that data request should be one of two things. What two things could it ask for? Temperature or pressure. So now I have to take different actions. I have to do different things based on whether the client has asked for temperature or asked for pressure. So let's do pressure first. So I can say if data request equal temperature, do the following if do the following if temperature is requested. What should I do if temperature is requested? Well, I should read the temperature. So I'm going to do temp C, and now I'm going to go out and read the temperature from the sensor. And I do that with going to my object. What was my object? My object up here was my sensor. So I'm going to go to my sensor. Okay. And what am I going to do? I'm going to do dot read temperature, like that, read temperature, and then open close parentheses, read the temperature. Okay, what do I want to do with it? Well, the temperature comes in centigrade, but I'm a Fahrenheit guy, so I'm going to convert it to Fahrenheit. So I'm going to say temp F is equal to temp C times 1.8 plus 32. What am I doing? Convert temp to F. All right, now I've made the measurement. I have the Fahrenheit temperature in the Arduino, which is the server. Now I need to send that data back to the client. So how are we going to send that data back to the client? Well, first thing we have to do is tell it I'm fixing to send a packet. So I go udp.begin packet, and then I have to give it two parameters. The first thing I have to tell it is the udp.remote IP. Okay, and we've set the IP address up in all the initialization, so it should it should already know, it should know these commands, so you don't have to do anything specific here. And then udp.remote port, and so we're telling it the remote IP and the remote port. Now it'll know the remote IP because that's the IP that made the request, and that information comes along. So when a client makes a request, UDP knows where the request came from, and this is just saying send the packet back to the remote IP, back to the guy that asked for it over the port that he's talking on. So this should work. Okay, so initialize packet send. So we're sending a packet. Okay, now what do we do? udp.print. What are we going to send? We're going to send it temp F, like that. Send the temperature data. Where did we get temp F? We got it right here. Now, we started the packet, we sent the packet, now we got to end the packet. udp.end packet. In the packet. So, when we send something on UDP, we say, start the packet, packet begin, here it comes, then you send it, then you said it's done. So you kind of start it, send it, and stop it. And this way you can send just these really nice little snippets of data using this protocol. Okay? Now we need to end our if statement. That's everything that we are going to do if it asks for temperature. What's the other thing it could ask for? It could ask for pressure. So if data request. Okay, so the next thing that we're going to look at is we're going to look at pressure. So in this case, if data request is equal to, always use your two equal to, twos, pressure, we do the following. So this means, in one time up here we read the packet. When the packet comes in, we read it. If the packet is equal to temperature, we do these things. If the data request is equal to pressure, then we do these things. So do the following if pressure is requested. Okay. What do we want to do? Well, what we want to do is we want to read the pressure. So pressure is equal to, who are we talking to? My sensor. What do we want to do? Dot read pressure, read capital pressure. You got to do it just right. Okay, read the pressure. After we read the pressure, what do we want to do? We want to send it. I'm going to make my life a little bit easier, and I'm going to copy this stuff, and I'm going to come down here, paste it, try to kind of get a little bit of alignment going here. Like that. Okay, only this time, we've read the pressure. This time what we are going to send back is pressure. So send the pressure data. All right, and then I should end this if statement. Okay, so I think I'm missing the end of this if statement. If packet size is greater than 0, yeah, so I'm going to end that if statement right there. This one ends there. This one ends there. We got to keep track of all that stuff. So let's go over this. I look and I see, is there a packet? If there is a packet, packet size will be greater than 0. What do? I read the packet. I read it into packet buffer. I change packet buffer, the array, into data request, the string. Now I look and I see, what is data request equal to? If data request is equal to temperature, I read the temperature, I send the temperature. If data request is pressure, then I read the pressure and I send back the pressure. Okay? Then there is one more thing that we have to do, and we have to remember that temperature and pressure are different sizes, and you've got to clear the array, because let me kind of try to draw over here what this would do. If I read into a character array the word temperature, it comes into an array of characters that would be T, E, M, P, E, R, A, T, U, R, E. Okay? So I would have all of these elements in the array. If I came back in a minute and I read it again and I read pressure, it's going to be P, R, E, S, S, U, R, E. Okay? But it's still going to have all of these characters that I didn't write over are going to come down. And so I'm not going to have pressure in the array. I'm going to have pressure and the extra letters out here, because overriding with a new read these positions in the array does not eliminate the ones that were there before. And so what I have to do, and I hope you will always remember to do this, otherwise you will go insane trying to debug your code, you've got to just clear that entire array out. And we clear an array in our Arduino using mem, set, and then what array do we want to clear? We want to clear out packet buffer. We want to blank it out, so we put a 0. And then how big do we want to go? We want to go all the way out to the maximum array size, which we know is this. Okay. This will ensure that we clear out the packet buffer array. Okay. So this, I think, is going to be a server, and I think this should work. I probably have made a mistake in here. I always hate it. It's hard to do this live in front of people. So let me click this. That wants me to save it. Okay. Save. Error compiling. What did we do wrong? Okay. Fatal. No such file or directory. Let's see. We will figure this out. Let me Ethernet UDP. Oh, I think I have an extra dot in there. Where did I do that? Okay, we will figure this out. right there, an extra dot. Did you guys catch that when I did it? I hope you didn't just blindly follow me. I hope you didn't do that. Okay, now let's see if it's going to work. Still doesn't like it. Ethernet UDP, no such file or library. I need to go back and look and see how did I do that. Ethernet, Ethernet, oh man, I really messed up. It's Ethernet UDP .h, like that. Okay, that was my mistake. Hopefully you guys caught it. Ooh, still not happy. Okay, import, include wire.h. Okay, let's see. Begin packet. Okay, it seems to be associated with my begin packet. Let's see what mistake we made here. Guys, I kind of like making, I mean, I don't deliberately make mistakes, but the nice thing is you can kind of see how we go about and do the debugging. And this seems to be, it doesn't like my udp.begin packet, so I say udp.begin packet, and then I go udp.remote IP open close, comma udp.remote port. The remote port needed to have the open close like that as well, and then close the overall thing. So you do udp.remote IP open close, comma udp.remote port open close, and then I've got to close out this one. All right, and then that I probably cut and pasted that down here in the pressure one as well, and so I need to straighten that out. Okay. So you look down here, and again, I wish I did this perfectly, but we all make mistakes, and I want you to see that when the thing goes orange, you don't fold up like a cheap lawn chair. You look at what it's saying, and you have somewhere made a little syntax error, a little typo, and you got to find it. Okay, still doesn't like it. Expected before UDP. So did I forget? Yes, I forgot to close that. Man, I did not do well on this line, did I? And it'll be there too. So you see I said it was expecting the semicolon. Okay, somewhere in here I forgot the semicolon. Okay, now let's see. Still doesn't like it. My sensor was not declared in this scope. So let's see how I did not declare my sensor. So let's see up here. I say my sensor, and then my sensor, checking my spelling, and then I will come down here in my void setup, my sensor.begin, my sensor.begin. Have you guys seen what my mistake is? Because I am not seeing it. Sensor, my sensor. A lot of times I misspell things and don't see it. So let's look up here. We have my sensor, Adafruit, F-R-U-I-T, underscore BMP085, my sensor. Okay. Then I come down here and I do in the void setup, my sensor dot begin. That looks good. And then temperature C equals temperature C equals my sensor dot read temperature. That looks good. Okay. My sensor dot read pressure. That looks good. So it doesn't like packet buffer, and it doesn't like, so let me look and see if I did something with packet buffer. when I declared my variables. Char, P-A-C-K-E-T, B-U-F-F-E-R, UDP underscore TX underscore P-A-C-K-E-T underscore max underscore size. That looks good. Packet size equal UDP parse packet, like that. Packet buffer. Okay, so I do a UDP.read packet buffer, comma, UDP TX packet max size. And then string data request PACKET BUFFER. Okay, let's look back up here and see if I didn't load a library right. Include Ethernet H. Okay. Let's see if I say, right here, Adafruit underscore BMP 085, my sensor, include Adafruit underscore BMP 085H. Something about loading this library I'm not doing right. Look at this. Okay. So you see, I hope you guys had seen this before I did. But look at that. I didn't have a C in include. And so it didn't get the library. Because it didn't get the library, it didn't set my sensor up. All right. I'm sorry that you had to go through that misery with me. But I hope you see how you know you've done something wrong and you have to find it. Hopefully, that's it. But now let's see. It seemed to still not like packet buffer. So we'll have to figure out what was wrong with that. Okay. Packet, it looks like I'm spelling it right. P-A-C-K, ooh, packer buffer. Oh, man. Another misspelling. I hope you guys found that. This is probably, if you saw me make that mistake when I went through it, it was probably pretty painful for you to watch me go in and have to do all this. So where did I spell it? Packer buffer. Okay. Packet size, packet buffer, data request, packet buffer, let's look up here. Declaring my variables, packet buffer. I spelled it right there. Where else did I use it? Packet buffer, packet buffer. We'll use the find command. P-A-C-K-E-R. It's when I reset it down here. Packet buffer. Okay. Now let's see, hopefully we got the problems out of the way. Okay, and I apologize. That was probably painful, especially if you watched me make those mistakes. But you make typos, and you've just got to go in and find them. Okay, I think that it's going down. I think it's downloading this time. So let's see. I mean, basically, what we can do at this point is we can just see, are we talking to are we talking to the Arduino? And what we can do is we can come up here and you will use your IP address, but see if you can ping it. Go to Windows, open a command line in Windows, and let's see if we can ping it. So I'm going to say ping 10.1.15.243, and let's see if we can ping that Arduino. Yeah, it's pinging. So that means that we have all this stuff set up right to where we are pinging it, and we're talking from the PC to the Arduino over Ethernet. Now we need to go in and we need to do our Python side. We need to do the client. So I'm going to say new file. And this we will go quickly because this is not going to be that hard. There's a library that we're going to need. We're going to need the socket library. So we're going to say from socket import everything. Okay, so we're importing the socket library. That's what allows us to create sockets, and we use sockets to talk over Ethernet. And I need to have delays, so I'm going to import time. All right, now I've got to tell it, who do I want to talk to? I want to talk to the Arduino, so I got to tell it, I want to talk to the Arduino. So I give it the Arduino's IP address. You will need to use your Arduino's IP address, not the one I'm using here. 10.1.15.243, and those are in single quotes like that. Okay, and I got to tell it the port that I'm talking over, 5000. Okay, define server IP and port. Okay, understand this is not the IP address of Python. This is not the IP address of your PC. This is the IP address that you're going to talk to, and that is the IP address of the Arduino. Okay, I need to create a socket, so I'm going to say client socket. That's what I'm going to name it. I'm going to talk to the Arduino over a socket that I'm going to name client socket, and I've got to create it saying that it's equal to socket, and then it's AF underscore INET comma sock DGRAM, like that. Explaining those two constants is beyond the scope of what I can do in this lesson, and so I'm just going to say set up the socket. Okay. Now I want to set a timeout. Client socket dot set timeout of 1 second. Okay. So this you'll only wait 1 second for a response. That's because if we ask for something from the Arduino and we don't hear back, we don't want it to just hang and the program end up getting stuck. So it's going to wait a second. If it doesn't hear back, it's going to move on. Now we've got to create the main loop while 1. Why do we say while 1? Because 1 is always equal to 1, so this is creating like the void loop in the Arduino. It's just going to continue to loop through. Okay. What am I going to ask for? I'm going to have a variable called data, and this is going to be what I'm going to ask for. What am I going to ask for? I'm going to ask for temperature. Okay, so I'm going to set data request to temperature. Okay, now that's what I'm going to ask for. Now I got to ask for it. I've got to send it to the Arduino. Where do I send it? I send it over the client socket, and I send it over the client socket that I created using client underscore socket dot send to. Where am I going to send it? What am I going to send it? I'm going to send it data, which was created here. Where am I going to send it? I'm going to send it to address, which was created up here. Okay. So I'm going to send the data request. Okay. Now, I've sent the request. Now I need to read the response. And I'm going to try to read the response. And why do I put a try? Because if something goes wrong, I don't want the program to crash. So it allows me to exit gracefully if I get a timeout or a crash or something. It says try. Okay. What do I want to try? I want to read the data receive data. So this is my variable that is a string that I'm going to read into. And then where do I read from? ADDR. Don't worry, client socket knows what that is. And now equals client underscore socket dot recv from, and then what size? 2048. I just make that nice and big to hold anything that I want. So I'm going to read response from Arduino. Okay, so let's look at this. I'm reading into the variable receive data. It's a string coming from address. Okay, what is it going to be? Client socket. That's how I talk. I talk and I listen over client socket, and then the command to read is receive from recv from, and then 2048 is the packet size. Okay, so at this point, receive data should have a string that has temperature in it, but I'm going to convert that now to a floating point number. So I'm going to say temp is equal to, let's float our received data. Okay, and now what I am doing is convert string received data to float temp. Okay, now we're going to print the measured, I like to capitalize, measured temperature is, comma, temp, comma, and then put a space, degrees F, period. Okay, and now we're going to print the result. Okay, now what do we want to do if something gets ugly and in my try it doesn't work? Well, we just want to keep going, so we're going to say except. This is where you end up if your try crashes. What do? Just pass, go on, do nothing. We're okay. Now we're going to delay time.sleep. We're going to delay 2 seconds so the data doesn't come through too fast. And so we're going to delay before sending next command. Okay. Now, I got a little trouble last time when I tried to cut and paste, but I'm going to try it again. And basically, it's the same thing that we're going to do again. Except this time, what we're going to do is we're going to, okay, I think that looks pretty good. We're going to ask for pressure this time. Pressure. Okay, we're still going to read the data into, or we're going to send it using client socket send to, and we're going to read it into the string receive data, only this time this should be pressure. And this time we are going to print pressure. And this time we're going to say the measured pressure is pressure, and this is in pascals, like that. Okay. Then I want to just, after we do this, what I want to have is just a blank line so that the data has, you know, sort of temperature, pressure, space, temperature, pressure, so we can see it. Let's see if this works. Okay, got to save it. Okay, does not like this. Line 12, client socket send to. Address is not defined. Okay, I probably misspelled something in here. So ADDRESS. Look at this. I misspelled it up there. ADDRESS. Did you guys catch that? I am just not at the top of my game today. I have made several typos, and I appreciate your patience, but I also want you to know there's a learning experience that any of us, when we write code, we're going to make mistakes. And a lot of times what I have is students come up and say, it's not working. Well, figure it out, right? Figure it out. It's just, if you get that orange bar, you made a mistake, and you have to look at the clues it gives you down there, and then you have to figure out what you did wrong. Almost always it's a typo. And so kind of hopefully, while it was probably painful, hopefully for those of you guys that are fairly new to programming, it allowed you to sort of see how to go through and figure out what you did wrong. So I'll try to turn that bad thing into a good thing. So let's try to run this again. Okay, save it. Okay, look at this. The measured temperature is a balmy 82.22 degrees F in this room, and the measured pressure is 92,961.0 pascals. And so this is just really, really pretty slick. Let me put my finger over here and let's see if we, oh, my finger's cold. Let's see if we can get it up. Okay, here we go. Okay, there we go. You can see I got it up to about 84 degrees. And so this is pretty cool. What this is sort of a simple client-server relationship where the client is Python. Python is sending requests to the Arduino. The Arduino reads the request over Ethernet and then does things based on what the client asks for. If the client asks for pressure, it measures pressure, it returns the pressure. If the client asks for temperature, it measures temperature and then returns temperature. What you can see is at this point you can just go and have at it. I mean, you can do whatever sensors you want on here, or whatever types of control that you want, because what you can see is that using the framework that I've shown you here, you can send a request from a client. The server will then do that command and then return the data. And the neat thing is that I could go to another computer over here and I could run this same program, and I could be asking for different things. Maybe this computer just asked for temperature, that computer just asked for pressure, or you're asking at different intervals or doing different graphics. You see, once you can get this data flowing back and forth and this control stream flowing back and forth, there's no limit to what you can do. Really appreciate you guys. I thank you for your patience as you had to watch me find my misspellings. I appreciate that you sat with me through this. Hopefully you liked this video. If you liked it, you might think about giving me a thumbs up, or you might think about subscribing to my channel. What I'm going to do is I'm going to come back with the next lesson will be lesson 18. And what I'm going to show you, we've got everything working here, but I'm going to show you in lesson 18 how to make things a little bit more robust. You know, on this one we did the try and accept so it won't crash, but it's actually possible with this configuration that I've given. It's possible for you to get your data jumbled up, and it's possible for things to get out of sync. And so in lesson 18 we're going to come back and we're going to show you how to make a more robust client server where we have a little bit more data checking in there. But for now we just sort of see we can get the data back and forth, and then we will move on to a little bit more sophistication in lesson 18. Really appreciate it, guys. I appreciate your encouragement. I appreciate your encouraging words, and hope you'll tune in next week for lesson 18. Paul McWhorter with TopTechBoy.com. See you guys.